Okay, so as it says, the upcoming things are you have to take home for next Monday. I think it's set up on Blackboard to just accept it by the end of the day. If you have trouble putting up on Blackboard, then you can email it to me. And on Blackboard, it's given 0 points. The whole idea is that since they're in groups, you'll only send in one for the group, and so therefore I can't have it graded that way. So that the points don't really matter. Today I'll probably end up a little early, so if there are any quick questions. Tomorrow afternoon I'll be around. Either you can email me questions, or if there are more than a couple, I'll set up a Zoom or Blackboard Ultra or a Collaborate Ultra thing. And then Monday I have the usual office hours from 1 to 3, so you can also do really last minute questions then. And then in 2 weeks, roughly, will be our second test. And right now there are 3 possible days, Wednesday, Thursday, or Monday. So either exactly in 2 weeks or the class before or the class afterwards. I could ask here, but usually a lot of people can't make this time. So I'll put a thread in under the discussion board, and I'll ask the 3 related questions. Do you have a test any of those 3 days? Do you have to take it at a different time? And which day do you prefer? And then on Monday, I'll let you know which worked, and we'll go from there. Or if I hear from enough people by tomorrow, I'll put it up tomorrow. So in some ways, what the test will cover will somewhat depend on when it is. So it'll be material past test 1. And now that I'm thinking about it, I forget exactly where test 1 finished. But once we decide what's actually on it, there will be a review like there was for test 1. So you will know exactly what's on it. It will probably just not be until next week. So for the quiz, I'm not sure. The original design was there was going to be a second in-class quiz and then a take-home quiz. I have to look at the schedule to see when things happen. It could be that I will do another take-home quiz that I'll hand out at the end of next week, beginning in 2 weeks, and then have it due after the test. But I haven't decided that yet. Partially it'll depend on how crowded I am for all the other classes. In some ways, that's what's on the syllabus, so I should try to do it, but we'll see if it works. So any other question about test or just general stuff? Okay. All right, so I stopped on Monday because we were starting the stock stuff, and that wasn't on the take-home yet. So I'm going to go back to that. So we're now into the stock. We'll do 1 or 2 examples of that, and then we'll talk about how we would extend that to continuous examples, which will bring us at least quickly into Brownian motion. Okay, so let me go to that. And let me remind you, we started an example. So let's continue that because we never quite finished it. And I'll just do the summary because this is the same as what we ended with on Monday, which is we're starting with the stock at $10. And it's going to go either to $5 or $50. And we had an option to buy the stock for $20 in the future. We let X be the number of stocks we're going to either buy or sell. If it's positive, we're buying it. If it's negative, we're selling it, just arbitrarily. Same thing for Y. If it's positive, we're buying the options. If it's negative, we're selling the options. And C is how much we're going to charge for the option. And when we got it, we got a couple nets. If the stock, it's supposed to be 50. If the stock's going to $50, we found that the net amount we make is 40 times X plus 30 minus C times Y. And if it went down to $5, then we got this. And the stock is pretty obvious, which is if it's $10 and goes up to $50, we made $40 on the stock. If it's $10 and went down to $5, we lost $5. On the other hand, for the option, it's a bit more complicated, which is if it's $10 and it goes up to $50, then we will buy it from using our contract for $20 from someone, immediately sell it for $50, which means we made $30. But then we have to subtract the C dollars that we paid for the contract. On the other hand, if it goes down to $5, we're not going to buy it from the other person for $20, so we just lost whatever we paid for the contract, so the minus C. And we found that there's a problem. If I just make up a number for C, such as 10, then there's a way to guarantee making money. So we ended it with this question. Which is, and as usual, it's smoothing out my writing, so it's not great. Is there a value of C so there is no arbitrage opportunity? And remember, arbitrage is something where you're guaranteed to make money. So there's a bet that you will definitely make money on. And we found on Monday that if C is equal to 10, there is such a thing. And so if there is a value of C that makes it so there isn't an arbitrage opportunity, then that is what we should charge for C. So this is just the recap of what we ended Monday with. So any questions on this? Okay, so there are two ways we can deal with it. Let me start in some ways with the more straightforward one, but it'll turn out not necessarily be the easier one. So the more straightforward one is what we can do is we can set up a system of inequalities and solve the system of inequalities. So we set them both more than 0 and see when there is a solution. And if there is, then that C doesn't work. So to get the idea, because it's kind of a pain to try to graph this if I have this unknown C, let's put back in the one we know is a problem, C equals 10, to see how this would go. So here's our system of inequalities. And so our first question is, because inequalities don't come up as much in some ways in college. So let me ask, how do I get the solution set for an inequality? It's kind of a two-step process. First step is to, actually, let me ask, how many people have solved systems of inequalities before? Is there anyone? No? Okay. So the two steps are, right, so the first step is you assume it's an equality, draw that line, and then decide on which side of the line is the solution. So here, I'm going to take this, assume it's equal, and that gives me a fairly simple one, y equals negative 2x. Graph that, and the way you graph a line is just get any 2 points. So for example, it goes through the point 0, 0, and when x equals 1, y equals negative 2. So we get that. And now we just have to decide on which side is the solution. And since it's either everything below the line or everything above the line, all we have to do is check any 1 point. So if I put in 1, 0 into that top inequality, I get the statement 40 is more than 0. Obviously, is that true? And obviously it is, right? Obviously, that's supposed to be a check mark. Obviously, 40 is bigger than 0. So here's 1, 0. That means everything on that side of the line is part of the solution set. So I'll just draw arrows showing everything above the line is part of its solution set. And then do the same thing for the other. So in this case, I get y equals negative 1/2 x. There's a line. Again, just get any 2 points, such as 0, 0, and 2, negative 1. And again, ask, if I put in a point that's not in the line, I might as well just use 1, 0 again, see what I get as a statement. So in this case, I get negative 5, 5 is more than 0. That's obviously not true, which means it's not in the solution set, which means the solution set is the other side of the line. So again, let me just draw some lines, some arrows, everything on the other side. And then the solution for the system of equations is anything that overlaps. So right there. So that's how you solve a system of inequalities. And it works with however many you want. Obviously, this gets pretty annoying once we get past 2 dimensions, because we'd have to try to graph things in 3 dimensions, which would be a bit of a pain. So this one does have solutions, which means if C is 10, then there will be arbitrage. So any point in the shaded region will work. So looking back at my original one here, the question is, what has to be true about these 2 lines so that there is no solution? And you can kind of see it if you solve the lines. So what would need to be true about the two equations for there not to be a solution? A little thing, because we're doing more than 0, we always go to the origin. So think about for a minute what happens if we change the arrow's directions. So if that second one is also above, notice we would still have a solution, but it would just be a different region. If I made the first one below instead of above, again, we would still get a solution. If I switch both of them, I would still get a solution. So what's the only way it works so that there's no solution? We would need it to be the same line. So if it's the same basic equation, then if one solution is above and one solution is below, then there's no solution. So if I make these into lines, this gives me y is equal to, which I'll bring to the next page, y is equal to negative 40, 40 over 30 minus cx. This one gives me y is equal to negative 5 over cx. Then I need those two slopes to be the same. So on the next page, I'll bring that over to show what's going on. But, so any questions on this setup? So this is how we would solve the system of inequalities. So let me bring it to the other page. No, the area, so the area in some sense doesn't matter. The idea is any points in there would give us a way of guaranteed money. So, for example, we found on Monday that 10, negative 10 works, and 10, negative 10 is in the solution set. So any point would be something that if I plugged into both equations would make them both bigger than 0, which would mean that it would guarantee making money. So we get this. Oops, and I lost an x. So we just set the two equal. So I'll get rid of the negatives. Yep. So if c is equal to 10 thirds, or 3 1/3, 333, then the two equations are the same line, and in that case, there would be no arbitrage, because one would be above and one would be below, which means that is what we should charge for our option. Okay. So there's one way of solving it. The two problems are this doesn't generalize very nicely, because as I said, if we start doing more than two possible bets, then it's a real pain to try to figure it out. And second, I forget what my second point was, but so nothing else, it doesn't generalize nicely to more than two dimensions. And for us, the bigger problem is it doesn't work if we're doing an infinite number of points, which is what we want to be able to do for stock. Because what we want to be able to do is say, well, stock can go up and down however much or however little we want. So there's going to be a second way. which is called the arbitrage theorem. So suppose there are m possible outcomes. So in our example we did, there were 2. This looks like it's not going to generalize to an infinite number of points, but it actually does. So it'll be a continuous case of the arbitrage theorem. Suppose there are m possible outcomes. With probabilities of each one occurring. It'll turn out we don't really care about the probability, but for the setup, it will matter. Then there's no arbitrage if and only if sorry, let me rewrite that. The second part, I'll have to remind you what it is. So suppose there are n possible outcomes, and there's no arbitrage if and only if there's a probability vector. So values we get for P1 and P2 and so on, so that the expected value for each wager is 0. In this case, what I mean by wager is there are 2 things we can buy. We can either buy stocks or we can buy options. Those are 2 bets. How many stocks do we buy? How many options do we buy? But in a more general setting, there can be lots of different things. So there could be a lot more than 2 possible bets. And as I said, the nice thing is this does generalize to a continuous case. So I can, instead of just saying, suppose there are n possible outcomes, we can say, suppose we have a range of outcomes with a certain density function. Then again, we have the same conclusion. So this generalizes nicely. So let me go back to the example, so say more specifically what's going on. So we have our probabilities. So we arbitrarily let P be the probability that the stock goes to $50, and 1 minus P is the probability that the stock goes to $5. And we now want to redo the equations with the different setup. So before we did it by what happens if it goes to $50, or what happens if it goes to $5. Now we want to say, well, what happens? What is the expected return on our bet for a stock? And it's similar to what we had. We know the expected value is the value times its probability. So if you go back to the example, if it goes up to $50, then how much money do we make? And it's just the same as before. We make $40, and we multiply by the probability of that happening. And then if it goes to $5, because we're looking at just stock, if it goes to $5, then how much do we make? So from before, we had the 40x minus 30 minus c times y. But here, we no longer have the x and y. We're just getting expected value. So we have plus the negative 5 times its probability. So our expected value for stock is given by that. So instead of doing for what happens if it goes to $50, we're doing what happens for the stock. And then the same thing for options. So if it goes to $50, we found that we made 30 minus c. And the probability of that happening is p. We found if it goes down to $5, that we lose c, and the probability of that is 1 minus p. So first, a little aside, let me ask just this setup. Any questions on how you get any of this? And of course, it's arbitrary what I call p, so I could have just easily said p is the probability that the stock goes to $5. Okay. So what the arbitrage theorem says is the way we figure out c is we need to find a value of p and a value of c so that both these equations can be set equal to 0 at the same time. If there's no such value of p, then there's just always arbitrage. And so you can see what we get is two equations with two unknowns, but it's easier than that because the top equation only has the one variable. So we get 40p plus 5p, so we get 45p is equal to 5. So we can solve for p, and we get 1/9. This one, let me simplify, because we have 30p minus cp minus c plus cp, so it's actually really easy. It's just 30p minus c. Yes, so c came from, so the 1 minus p is that the stock goes down to $5. If the stock goes down to $5, then the option is worthless, so we just lost whatever we made. So the negative c is our net gain if we buy an option and the price of the stock goes down to $5. So we get p is equal to 1/9, and you can see this one then gives us c is equal to 30p, and we again get, of course, better, the same value we did last time, 10/3. P by itself doesn't really mean anything, so the fact that we found p was 1/9 doesn't really mean anything. It just says for this value of c, there is some probability so that we're not guaranteed to make money, which means since we don't know what the probability is, we're not guaranteed to make money. Any other value of c, we would be guaranteed to make money. So the second way is, in some sense, the easier way of doing it. You can see the equations are fairly nice. And as I said, it generalizes. So if instead of having two prices in the future, there are three, it's a little bit easier to set up and figure out what you would need. So any questions on this? So I'll only do one more of these, just different numbers. There's much I can do. And then we'll talk about how we're going to generalize that, which will get us into Brownian motion. And I'll be lazy again. So the stock right now is at $50, and it will go either down to $25 or up to $150. And have an option to buy the stock at, let's say, $75. And we're going to let C be equal to the price of the option again. And again, arbitrary what we allow P to be. So this time, just to be different, to show it, I can do it either way. Let's let P be equal to the probability that the stock goes down to $25. And let's do it a second way. And we want to find the two expected values. So the two things that can happen is either the stock goes down to $25 or it goes up to $150. And right now we're just looking at stock. So if the stock goes down to $25, then how much did we make or lose on each stock? And let's do make and just, yeah. So we're going to get a negative 25 times the probability of that happening, which I said was P. If it goes up to $150, how much did I make? And so I get this. And according to the arbitrage theorem, I'm going to set that equal to 0. And either I can solve it now, because you can see it's only the one variable, or I can wait until I do the other one. So same thing for option, this slightly trickier one if you haven't seen this before. If the stock goes down to $25, how much did I make with the option? So the minus C. And remember, the idea is what's happened is the stock has gone to $25. I have a contract with someone to be able to buy it for $75, but that would just be silly, because why would I buy it from $25 from the person I bought the contract from if I can buy it from anyone else for $25? So I just lost whatever I paid for that contract, which is C dollars, which is what we're solving for. Okay. And same thing, if it goes up to $150, how much will I make? And again, think about what's happening. So what would be, how much would I make if it goes up to $150? Okay. And again, times its probability. And the reason it's that is what's going to happen is so in some sense, I don't care about the original price for this case. So if it goes up to $150, I'm going to use the contract, buy it from the one person for $75, immediately sell it for $150. I just made $75, but then minus whatever I paid for the contract. And again, I would set that equal to 0. Okay. So any questions on the setup of the two equations? Okay, so now we want to solve them. So like the last one, we can just solve the top equation by itself. So these are systems of equations, but it really is easy. So we get the 100, and you'll double check my numbers here, is equal to 125p. Therefore, C, in our setting, C is kind of a percentage type thing. So we need to do it for every stock. So if I buy 10 stock, I have to pay 10C. That's 4/5. And then this one again simplifies because I have the CP, that will cancel out the CP, and I'll have left with 75 is equal to 15, yeah, I'm not sure why I'm having trouble here. Do it the easier way is it's 75 is equal to 75 times 1 minus b is equal to c. So yes, 15. So here's the idea. As I said, we're really only doing this to get the idea of it because it's not assumed you've done any finance or stock stuff. So this really is just a trigger, but I will probably put it on the test. Hopefully that means it'll be an easy question, but you'll tell me. So any questions on this? So let's at least quickly, and we probably won't get through the whole thing, but let's quickly talk about where we want to go from here. So the units for C are just usually dollars, so now I'm not going to worry about that. So here what we want is a continuous probability distribution. And what we're going to do is what's called Brownian motion. We'll do one-dimensional one, but if you've never heard this before, you can actually see Brownian motion in action, at least theoretically, which is three-dimensional. If, for example, you pour milk into tea, the way it spreads out is Brownian motion, which is just randomly moving around. So as one molecule hits another one, it will randomly go in a different direction, and that motion is Brownian motion. So this is going to start with something we did a little bit with. Which is a random walk. If you remember, we talked about this quickly, but then we said, well, we don't want it to be infinite, so we made it the drunken walk so that it would be finite. But let's go back to that it can be infinite. So wherever we are, so we'll start at 0, but wherever we are, we're going to move either left or right with equal probability. So if I'm at 0, and just to start, we'll move by 1 unit. So I'm either going to move to the right with probability 1/2 or to the left with probability 1/2, and then same thing forever. So I'm just moving back and forth. Call this the random variable di. I forget why I'm using d, but it doesn't matter. Should be obvious. What is the expected value of di? Just 0. Either, since I'm going left or right with equal probability, the average amount I move is 0. So in some ways, think of d as the amount I moves, so I don't care where I am. And I can do the same thing with the variance. In theory, this should mean we should get E of d squared, but should be fairly intuitive what the variance is here. What is the variance here? How much do I change by? 1, right? Because I'm either moving 1 to the right or 1 to the left, and the variance, I don't care about the sign. So on average, I'm moving by 1. Okay. Now what I want to do is talk about where I am. So let's let xn of t be the sum of n of these. And we want to make it into a continuous thing, so we're going to put in a t. And for this simple one, we have exactly what I drew in my little picture, which is we're going to move, for example, once every second, so a unit time interval, and we're going to move by 1 unit measure. So from 0 to 1, from 1 to 2, from 2 to 1, and so on. And t is just going to be, well, so I guess the other way is the n. In some ways, this is all leading to something, so we don't really need this. This is just to get where we're going. N will be the maximum. That's supposed to read maximum integer less than or equal to t. So if we were doing x of 13.21, then n would be 13. And I said, don't worry about it too much. We, of course, are assuming that the moves are independent. So I'm going to put this on the next page. But what is the expected value then of the sum? So what is the expected value of xn of t? Let me leave it here so we can, and then I'll put it on the next page. 0, because we know that expected value of sum is sum of expected values. Each sum is individually 0, so 1. And if I look at the variance of xn of t, what will that be? In this case, I do need the independence, because if the things are independent, the variance of the sum is the sum of the variances, which means the variance of xn of t will be n. So let me bring that to the next page. As I said, this is just leading up to what we really care about. And now what we're going to do to make it Brownian motion is we're going to let two things, we're going to look at two limits. We're going to let the time between moves go to 0. So we move in some ways a bit more quickly, but we're also going to let the distance you move in each step go to 0 also. That way we'll now start getting continuous movement with continuous time. And I'm going to skip the little steps of how we show what this goes to, but we can let the limits go at different rates, which means in some ways we control this a little bit. So and I'll leave off what the base is, because in some ways there are the two bases, because we're changing two things at once. So we're looking at the limit of xn of t. So one of them is obvious. Expected value of b of t is still 0. Because we have the ability to change the limits at different rates, in some ways we can make the variance almost anything we want. Except it has to involve t. And as I said, I'm skipping the loop proof to see why we actually do need the t there. Kind of makes sense, which is, as a sum, it is the sum of n things, and the variance is n. Here, in some sense, we're summing up through t, so we get a t. So we get this. Let me ask a different question, which is the xn of t for large n. Oh, that's a sigma. Sorry about that. So So from 3081, we know that if we're looking at the sum of a large enough set of independent random variables, we get the normal distribution. Therefore, xn of t is the normal distribution with the given mean and standard deviation. Well, that means that since Brownian motion is the limit of xn of t, Brownian motion is also normal. We're not going to get to it today, but let me talk about why this might make sense. What we're going to assume for the stock is we're going to assume that the percentage change of the individual stock per day is independent of what happens the next day. And if I look then at that, I will have x0 times a percentage times a percentage times a percentage. If I take the natural log of that, I can make it into a sum. And so I can assume that that then is Brownian motion. So with a little extra that we're going to have to add in, we are going to assume that the natural log of the stock price is Brownian, that it's going up and down randomly to some extent. As I said, there's going to be a little bit more to it, but that's why we're doing this. So in the assumption, we're assuming that the percentage change of stock is independent of each day, which probably is not right, but we'll pretend it is. Okay, so let me just do the one last thing, and then as I said, we'll stop not too early, but a little early, which is Brownian motion is normal, but it has two nice properties. First is that the change position are independent if there's no overlap. So for example, change position from 2 to 7 where it goes from 2 to 7 is independent of where it goes from 10 to 12. So as long as those time periods don't overlap, they're independent. So if I tried b of 12 minus b of 1, that would not, because since they overlap, obviously they can't be independent. And the second, which will make it so we can actually do this more easily, if the time difference is the same, the difference is really being bad about my writing now. Have this, the differences have the same the time difference is the same, the distributions have this, the differences have the same distribution, sorry. So example, so b of 9 minus b of 6 has the same distribution as b of 5 minus b of 2 has the same distribution as b of 3 minus b of 0. So as long as the time difference is the same, they have the same distribution. So here we're not talking about independence, just the distribution. And this last one lets us actually do it because we're assuming we're starting at 0, which means b of 0 is just the point 0, which means this last one is just b of 3. So if I want to find the probability of a change from 6 to 9, that's the same thing as saying what's the probability that it's at a particular point at time 3. And since that's now one variable and it's normal, we can do that pretty easily. So we can do, at least in one dimension, we can do Brownian motion fairly easily. So that's what we'll start on Monday. And then we'll go into how I make a model for stock price. So this is what we're looking forward to. Also, this will mean that we will start using normal distributions. So go back to 3081 and see if you solve the table, and or use it, see if you remember how to do it on normal distribution probabilities on your calculator. So we'll do that for Monday. So any questions on this? Okay. So let me stop the recording, but we have another 10 minutes, so I'll stick around and you'll let me know if you have questions about the take-home.